Welcome to this video tutorial on how to program number 11300, top, point, and circle indirect. So the focus of this video is to show you how to measure indirect features. And when I say indirect features, I mean features that cannot be output directly from the features that you measured to the dimension report. So let's take a look at our datum scheme here. So we have datum A is the top surface, datum B is the front, datum C is the left side. So that means we can go with our standard plane, line, point alignment. Now for this video, to save some time, I'm just going to open up an existing file with that plane, line, point alignment already done. From there, notice that I have to measure the distance from this step over to this step along X and along Y. That would be balloons 1 and 3 respectively. I also have to measure the distance from step 2 over here to the X overall, and then from step 1 to the overall, that would be balloons number 4 and 2 respectively. So I have a couple of things that are coming not from the origin. If I simply touch this step right here, I'm calling this step 1, and I output its X position, that would give me the distance from the origin at the left edge all the way over to that step, and I don't see a dimension on the print that's asking for that. If I were to touch this step right here and then output its Y position, that would give me the distance from datum B up to this step here, and I don't see that dimension on the print either. So this print was specifically crafted so that none of the dimensions can be output directly from the features. So let's get into it and see how to do it. With that said, let's think about how we're going to measure this. I'll open up a file that already has the alignment done, and then I'll measure, let's see, a point over here to know where this step is, a point here, a point here, a point here. It looks like we don't even need the X overall and the Y overall at first sight, but if we think about it, to be able to output the position of all these holes, here, here, and here, in the Y-axis, all of those are pulled off the back edge. So we're going to need to know where the back edge is, so we'll have to touch a point there as well. And then to output this 630 dimension and this X dimension, we're going to have to pull from the left edge, or I'm sorry, from the right edge over. So we're also going to have to know where this right edge is. So really, in terms of the actual points measured in this file and the circles, this is really going to look a lot like the last two files that we made put together. It's just the characteristics that we're going to output based on that are going to be different. So we'll measure a point, a point, a point, a point, a point, and a point. And then we'll measure 3 points on a circle on each of these circles. Now, you'll notice that I have since automated, since the initial video where we learned how to measure these circles, I have automated my strategies for how to measure these circles, and I'll show you how to set that up in a separate video. If you don't see me clicking on individual points here when I measure those circles, it's because those strategies have been automated. So let's get into it. We'll see how good my memory is as far as what features we need to measure. So here is my standard alignment program. I'm going to open that up, and I suggest you do something like this as well. If you can reuse alignments for these assignments once you know what you're doing, go ahead, save yourself some time. The first thing I'll do is hit File, Save As, and I'll save this to my Downloads folder, and I'll save it as the name of this assignment. And the name of this assignment is 11300 point circle indirect. Then I'll put my initials at the end of it. I'll also put OFF at the beginning, which just tells me when I'm looking through my files that this is an offline file. This is not a file that has been proven on the machine. All right, so I open this up and I see that my plane, 2D line, and point have already been measured. I actually like to throw those into a group. I should have done this in my template. Now I have to do it every time. And I'll name this Automatic Alignment. And say OK. So now when I start touching these other points, I won't get them confused with the last point that's part of this alignment. So that's a nice little trick there. So let's come in here and hit the pull down and click Define Points. We want to measure a point here. And I'm not even going to worry about renaming it. I'm not going to worry about outputting X, Y, or Z because remember, these are indirect characteristics that we'll output. And this menu only supports being able to do direct characteristics. So I'll simply hit enter there or OK. And I'm going to measure that, hit enter, that, hit enter, and so on and so forth. So I'm just measuring these steps as we go. And those are all the points that we need. And the next thing that we need is the circles. So we'll hit the pull down, we'll hit define circle on cylinder. We'll measure 1, 2, and 3 circles. And notice that what I've done here is quote unquote path efficient, meaning it moves in a way that is going to minimize the cycle time. So let's go see how that worked. We'll go into planner and measurement plan simulation. We want to make sure our speed is all the way maxed out, and then we'll hit the arrow to the left one time. We'll resize this a little bit so that way we can see as much as possible. We'll set that to base alignment just so our numbers make sense, and then we'll dock this here. And notice that I have collision observation turned on. If it's off, that menu at the bottom, that white space goes away. If it's on, that white space comes back. All right, so let's go into our run menu, and we will clear existing results, default PyWeb reporting, automatic alignment, all characteristics. We're going to do it from feature list. We'll use clearance plane, slow through first feature, 55 millimeters a second. So there's our alignment, and it doesn't do anything else. And the question is, why is it not doing anything else? Well, right now, we don't have any characteristics. So if we don't have any characteristics, and I'm just telling it to do the alignment plus whatever characteristics we have, even if I'm running it from the features menu, when I run it from the features menu, it's only taking the order. It's not taking all the features. So in this case, because I have no characteristics, if I want to run it, I have to highlight everything. So I click on the bottom, hold shift, and click on the top. I hit run. I'm going to leave everything else the same here, but I'm going to turn on current selection and hit start. And now we'll see if it looks any different. So there's our alignment that we got last time. Aha! And now it's touching all these points. Looks like we have some really weird things going on with our clearance planes by default. And that's fine. Notice also that the simulation can be a bit painful when we have our circular movements on, especially if you're moving at a low speed. That simulation can be really painful with those circular movements. So I'll show you a couple of tricks for fixing the clearance plane and the circular movements. So notice also that collision observation did not pick up any collisions, and if there were any, it should have picked them up because we were not at full speed here. So that is a good sign. So my next move is I'll come into measurement plan editor features, and I'm going to make sure that our stylus system is not set to the default. So I've learned since the first couple videos that if you have these blue stars in here, it says from higher setting. Basically that means this is going to pull the default stylus on the machine. Right, so we're just going to forcefully reset that so that we get black text. We want to use the 3 by 50 millimeter stylus on this. All right, and notice that this is all black. That is good. That's the stylus we're using. All right, so the next thing we're going to go to is travel, and let's go to retract distance, and notice that these are blue as well. And I'm going to grab all of our alignment features, and I'm going to forcefully put that at 250 thousandths. Notice that it turns black when I hit enter. And then I'm going to take all the other features, and I'm going to set that to 50 thousandths, and that will make the program run more efficiently, and it'll fit in small holes better. Another thing is arc motion mode. You see that that's on for all of these? That can cause the simulation to go painfully slow, especially when you take this speed slider and slow it down. So I'll hit the pull down and turn all of those off. And everything that I did here, by the way, is a good default. You should always do that in all of your programs before you run them on the machine. Let's also go to clearance group, and you can see that we have plus Z, plus Z, plus Z, and then we have a plus Y, we have another plus Y, a couple of plus X's, and notice that the plus X is on a feature where the normal vector, which is a line that points perpendicular away from the feature, the normal vector points to the X plus, and our clearance plane is X plus. Same thing here. The normal vector of, well, okay, so that's an interesting one. Our clearance plane is X plus, but our normal vector goes Y plus. So Calypso has some sort of secret sauce in the background that it's using to determine clearance planes. I don't want it thinking so hard. I just want the plus Z axis here. So with those in mind, we will come back through and rerun that exact same program. We'll just come to the Features menu, we'll hit Run, and we'll hit Start. Now let's watch how this goes. Okay, so now we get some other weirdness out of our measurement window. We hit Run, and those parameters worked just fine last time, but now it's not running anything other than the alignment. Let's drill down and figure out why. Well, first of all, I did have everything selected, so that wasn't the issue. You know what the issue is? I did have all characteristics selected somehow, so let's do current selection instead. Now, another thing that might be an issue is Calypso is only going to measure whatever it needs to measure to compile your dimension report. So right here I have clear existing results checked on. If you ever see something like what we just saw, you go to execute the program and it doesn't do anything, make sure that this button is checked on. If it's checked off and it doesn't clear the existing results, it is simply going to take the results it already has from last time, find out whatever else it needs to create your dimension report, and then measure whatever it needs and nothing extra, right? So this window can be a bit confusing, especially when you're new. It is also sensitive to what you're selecting over here, so watch out for those things. You notice that now with that arc motion off, the circles are being measured much quicker. Notice also that the clearance plane selection did influence how the probe was moving out here pretty significantly. So the feature settings editor is a good way of fixing all of those automatic issues. All right, so that was pretty easy. Let's take a look at our SOP for writing programs and see what we should do next.